Hello, algebra classes, and welcome to an entirely new chapter, Chapter 10, where we're going to be taking a look at data and making sense of data that we can collect on a variety of different subjects. So we're going to begin by looking at lesson 10.1a, where we're going to learn about analyzing what are called surveys and samples. So here's the idea. So let's say we want to find out about something for a particular population. A population can be any group that you want to study. It can be all the people in the United States. It could be people at a particular hospital. It could be students at a particular school. It could be a set of trees that you want to find out something about. It can be anything at all. Well, there's lots of ways that we can gather our data and find out about that particular population, whatever we define that population to be. Some sampling methods help us understand what is happening in the entire population more easily than other types of samples. Some samples don't really represent truly what's happening in the entire population. Now, why don't we then just study an entire population of whatever it is that we're trying to find out something about? Well, we can, and in fact in the United States each year there are, every 10 years there's something called a census, and the census finds out about data about every single person in the United States, or it attempts to do so. That's a very large task, and so we can actually find out what's happening in a particular population by selecting particular members of that population, and as long as those members of the population represent the entire population, if we pick a good sample, then we'll know what is happening in that entire population. So we're going to take a look at our key concept here, and this is where we're going to begin writing. We're going to look at some sampling methods. Some of these sampling methods work very well. Others work under only certain conditions. The first type of sampling method is called a random sample. Well, we're trying to find out something about every member of the population, and we're only going to pick some people to represent what's happening. And so a random sample works this way. Every member of the population has an equal chance of being selected. And if you pick a large enough sample, let's say a tenth of all the people in the United States, as long as it's random, you should have a pretty good idea of what's going on in the entire population. Another method of collecting data on a particular population is called stratified random. A stratified random sample will take the population and divide it into distinct groups. Maybe you would break it up by state. Maybe you would break it up by age group. You would pick a way to group all of the population, assuming your population is fairly large. This might be a good first step. And then you randomly pick members within those groups that you have made. So if you are using the idea of you want to find out something about the population of the United States and you group the population by states, then you would maybe pick some people that are in each state to find out something about the entire population. Systematic sample, well, that's where you use a particular rule to select the members of a population. And it might be every 20th person once you have a list of all the people that you are interested in finding something out about. So systematic sample is a sample based on a rule to select your members. A convenience sample, well, a convenience sample and our last one, self-selected sample, those don't necessarily represent the entire population very well. Here's how a convenience sample works. Only members of the population who are easily accessible are selected. So if you are a person who has been tasked with finding out the favorite ice cream flavor of all the people in a particular city, and you sit on the sidewalk outside of an ice cream shop and you ask that question, because it's convenient to ask those people who happen to be walking by for you, you might not get a representative sample that shows exactly what the entire population is thinking. Self-selected sample. So in this particular case, again, you might not get a representative sample of the entire population because a self-selected sample, it works this way. Only members of the population select themselves by volunteering. So now, for example, if you went to a movie theater and you said, you know, at the end of the movie, if you want, you can fill out an evaluation of the movie. You don't have to. Well, you might not necessarily get a representative view of what people really thought about that movie, because in that case, only people who feel very strongly one way or the other about the movie would be likely to select themselves and actually fill out the question. All right, so let's go ahead and see if we can identify the sampling methods that are used in particular surveys that have been conducted. So here's some board problems. So starting with A, we're going to determine the sampling method used. We're going to pick from the ones that we just went over, the 5 choices above. So let's say a student asked other students sitting close by, hey, what is your favorite color? Because they were conducting a survey of the favorite colors of students at their school. Well, that would be a convenient sample because it was convenient for that student to ask students who happen to be sitting close by. That may or may not be a representative sample of all of the students in the school, all of the students being the population that's being studied. Okay, board problem B. Let's say the principal puts the names of all students in a box, and then that principal drew out 50 names and asked these students, what time do you get up on a school day? And perhaps the survey was trying to determine what is the typical time that a student gets up in the morning to come to school. Well, that would be a random survey, and random surveys can be a pretty good choice to come up with a representative sample of the entire population. So if there were, say, 300 students in the school, so 50 out of 300 would be a pretty good size sample and should give you a pretty good indication of the typical time a student gets up on a school day. Board problem C. Imagine every 20th name on an alphabetical list of all students in a school were selected and asked, how many siblings do you have? So for this particular survey, it might be a situation where we're trying to figure out the typical number of siblings that a particular family grouping has at that school. Well, that would be a systematic sample. There's a rule that's being followed. You've got an alphabetical list, you pull off every 20th name, and that person gets asked the question. So these 3 sampling methods, random, systematic, and then our next one, stratified random, these are pretty good ways to be able to get a pretty good representative sample of the entire population. All right, letter D. 10 students were randomly picked from each grade level at a school and were asked, what is your favorite food item that the cafeteria serves? So you're imagining that the cafeteria workers are trying to figure out what items they should be preparing each day to maximize their sales. So that would be a stratified random sampling method because first all of the students were grouped. They were grouped by grade level. And then students from each of those groups were selected and asked the question. So stratified random, first make groups of the entire population and then randomly pick people from each of those groups. So again, random, systematic, and stratified random typically are going to give you pretty good representative samples of an entire population, so you can have a pretty good idea of what's happening with everyone or everything in that population without actually surveying every single person. Letter E, board problem E. Students in a particular class were told they could fill out a course evaluation if they wanted to do so. Well, that's a self-selected sampling method. And again, you may or may not get a representative sample running a survey in that way because typically you're only going to get students who feel very strongly one way or the other about that course to fill it out. So that wouldn't represent the views of perhaps the many that are neutral and in the middle. All right, so moving to example 2, we're going to take a little different look at our surveys. We were concentrating on ways to get some good samples from a population to figure out what's going on. Well, in example 2 and in example 3, we're going to look to see how we can have some bias, some ways that actually aren't going to help us understand exactly what is happening in a particular population. So let's see what's going on in example 2. It says to identify the bias in this survey sample. So the owners of several factories conduct a safety survey to determine which employees were informed about safety regulations. 50 employees at one of the factories were chosen to complete the survey. And remember, there were several factories. And so if we ask only the workers at one of those factories, that might not actually be representative of the entire population. Perhaps there are factories spread across the entire country, and perhaps the factories in California had really good training about safety, and perhaps those in, I don't know, Minnesota or Alabama didn't have particularly good trainings. So you could get some very different results by just looking at the results of the employees at one factory compared to selecting some members from each factory to answer that survey. So this is an example of bias in a survey sample. They're also going to be biased in the way you ask the question in your survey. And example 3 is going to show us how that looks. So on example 3, we're to rewrite each survey question so it is unbiased. Each question on example 3 have been asked in a way that suggests a particular way the answer should come out. So on letter A, it says, don't you agree that the voting age should be lowered to 16 because so many 16-year-olds are responsible and informed? Well, that expects the answer, yeah. If the 16-year-olds are responsible and informed, why would we not want them to be voting? So that expects the answer yes, and that's a biased question as a result. So our job is to rewrite that question so that it's not biased, so a particular answer is not expected. One way to rewrite this question would be to say, do you think the voting age should be lowered to 16? That doesn't expect a particular answer. So that would be an unbiased question that you could use for your survey. Example 3, part B, well, we're going to look at another biased question, a question that expects a particular answer in return by the way it's written. And so the question here is, do you think the city should risk an increase in pollution by allowing the expansion of the Northern Industrial Park? Well, the way that's written, you would expect that people would say, well, no, I don't want an increase in pollution. I don't want the expansion of the Northern Industrial Park because that would make more pollution. No, 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 no. So that expects the answer, no, we don't want the expansion of that park. How can we rewrite that question so that we can get a fair assessment that doesn't expect a particular answer? Well, one way would be to write the question, do you think the city should allow expansion of the Northern Industrial Park? That's a fairly neutral question. So people can then weigh in with their own opinion without a particular answer being expected. All right, so this is going to get us into our whole chapter on data analysis. So we're thinking about how we can ask questions and collect data, some good representative ways we can collect data when we're looking at large numbers that we want to get information from, how to write some of those good questions, how we can conduct our surveys so that they actually provide us with the information that will help us understand what's happening with an entire population. So you're going to work on problems similar to this on your own today, and then know that tomorrow you're actually going to be conducting a survey, and you don't really know how to do this very well yet and what to do with the data because we're just beginning our study of data analysis, but you'll have an opportunity to go ahead and participate and collect some data, and then we're going to spend the rest of the chapter figuring out what we should do with it to be able to interpret it in a way that makes sense, that gives us information about the population that we're studying. All right, so have a good rest of your day, and we'll see you next time.